Hello, pardon me for a second. Hello, hello. I will say hello in a second. I'm trying to switch. Hello, hello, everybody. Hang on, I'm just trying to fix my
Hello.
audio. Hello. Okay, so you can hear. Excellent, excellent. Give me a second. I'm trying to change the audio situation. I'm trying to change. Every day is a new hardware. Okay, hello, hello. I'll say hello properly in 1 minute. I'm just trying to get the board and the audio, but it's good to see you all. Hold on, hold on. And I know there's people in the waiting room. Bear with me for a second. Okay, okay. Wait, more people coming. Okay, I think we're getting there. Okay, I'm going to start saying hello in my more official way, but let me know. I'm thinking right now. Let me know as I'm saying hello. Um, I think we're okay on audio. Like, I think, well, I'm pretty sure I can hear you. I think you can hear me. Hello. Good. Okay. Good. Excellent. All right. Well, first of all, but tell me if you're not hearing me, or maybe even confirm it's good. Okay. Great. Great. Great.
I
Thank you.
can
Okay.
hear you.
Awesome. Awesome. Okay. Awesome. So I'm going to say, so this might be our best hardware day yet in the last three. Okay. So hello, Josephine. Hello, Claudia, who I met in person. I'm just saying. Okay. Hello, Victoria. Yes. Hello. Okay. And hello, Paulina. Hello, Cheyenne. Hello, Katie. Hello, Emily. Hello, Logan. Hello, Alexis. Okay, that was my visual hellos. Now this is all meant to be friendly, but I guess it also constitutes tech test. Okay. Good afternoon, Cheyenne. Hello, Katie. Good afternoon, Claudia. I'm in the chat now, obviously. Good afternoon, Shawnee. Good afternoon, Paulina. Good afternoon, Alan. Good afternoon, Maria. Hello, Shawnee. Oh, right. Got it. Good afternoon, Alexis. Hello, Logan. Oh, thank you, Alan, for the feedback. Okay. Literal and figurative. Afternoon, Eric. Thank you, Paulina, for the feedback. Thank you, Brand, and hello, Brandon. Thank you for the feedback. Hello, Victoria. Good afternoon, Jenna. Yes, well, Claudia, good question. That is definitely the goal. I mean, that's a very appropriate question of Claudia's in the chat. Certainly, that's the goal. But I also do know that I'm a little bit behind. So the good news is that's the goal. That is the goal. Actually, maybe I'll start. You know what? Okay. Well, let me finish saying hello. But I'm actually going to take that even more seriously than maybe Claudia thinks. We'll see in a second. But okay. And yes, okay, because Cheyenne is echoing Claudia's question. Alan is echoing. Oh, okay. Okay. I'm just going to read this all out since I'm still saying hello, but I totally hear Claudia. I totally hear Cheyenne. Alan has a slightly different point. I'm going to address that in a minute, and Cheyenne, but good afternoon, Emily. Hello, direct chat person. Good afternoon, Jada. Good afternoon, Revo, whose name I still might be mispronouncing, and I apologize. I think I'm saying Revo, but please tell me. I know we've been through this before. I apologize. All right, now let me address. Those are some good questions in the chat. Actually, I will definitely. Let me go in opposite order. Right. Okay. So thank you, Alexis. Yeah, yeah, yeah. Like, and no shame, no gain. But I'm actually glad. I appreciate that Alexis is confirming that at least I'm not that I didn't make two mistakes. Just to be clear, yes, to to I just lost it. To the thing that wait, now I lost someone. Oh my God, I'm sorry. Oh, and someone else is here. Now I've lost it in the chat, but the person that was asking about that equation that they couldn't find or couldn't be identified, yes, that was a total error on my part. That was when it made a reference to an equation on a website. Yes, I mean, that was a very old website of ours before we had Google Classroom. And for some reason, every semester I forget to take that question out of the sheet or something like that. That was a total error. And the idea is you could just ignore. Yeah. Okay. So what Eric, I keep losing it in the chat, but yes, yes. The reference to the website equation is my error. It's an old, I have to fix it. There's nothing you could just ignore it. There was nothing you could do about that or should do about that. It was on me, not you. I do apologize. It's a fair question. But yes, also, oh, it was Alan's. Yes, Alan's questions. Right. So fair enough. And I apologize, Alan and Cheyenne, and maybe you can acknowledge in the chat if I've addressed. But it is true, just for the record, also what Cheyenne is saying. No, sorry. What Alexis is saying is also true, that someone had brought that to my attention, that error was still there. And I did put in the stream something like, please ignore that. That's my bad. And I'm just saying that but of course, with all of us, it takes every semester. I still haven't fixed that error. So I'm human. And so just because I put something in the stream doesn't mean that everybody catches it immediately. So I'm glad you're raising it here. But yeah, but just know, let me put it this way. If heaven forbid, or quark forbid, say there's something on the exam, when the exam comes, if there's like something that just doesn't seem right to you, that is confusing you or giving you stress, and it might be my error, but it might not be, right? You're definitely welcome to reach out right then and there by text. Like, that's really what texting is the best thing for, especially for an exam. And you're like, wait, I think something might be wrong here, but I don't want it to be on me if you're not. You text me and say it. And then and that's what someone did here in this, and then I will try, especially if it's an exam, I'll try to correct it directly in the exam, but there's no way anybody would know that unless you check the stream and stuff like that. So what this means, of course, I don't want people like every minute checking the stream or like having their phones on at 1 a.m. But the minute you think there might be an issue with something, definitely go back and triple check if anything has come up in Google, because you're probably not the only one. So maybe someone else did bring it to my attention. And then I will try to publicize things fast. You understand what I'm saying? Just like, if you think there could be an error of mine, definitely reach out to me. But if you don't get a response, look to see if maybe anyway. So that equation was an error. My bad. There's no website equation. Now, oh, that's a fair question, Claudia. Oh, thank you, Alan. Wait a minute. But yes. Okay, we'll get to that when so Claudia is asking in the chat, can you text me during the exam? So the fast answer is yes. Okay, the slightly slower answer is yes. No, I'm just, the slightly more elaborate answer is you can text me during an exam. Depending on what question you ask, I might not answer. Like, there's certain questions that if you ask me, I won't answer. There's a lot of questions that if you ask me, I won't answer. But especially because the exams are take home. We'll talk about that when we get there. But the exams are take home, and they're not like webcam exams or whatever. So especially if you think there's a possible error or something weird about a question, if you're having a hard time understanding an instruction or question, honestly, you should text me, because you might not be the only one. I won't help anybody with content during an exam, just to be clear, like what Claudia is asking. With homework, I would. But with an exam, no. You can't text me and say, can you help me with, and what you definitely can't do. Okay, sorry. I know we should move on. But, I mean, these are legitimate questions, especially with Claudia. What I won't do, people do this all the time, and they try to trick me with this all the time. Don't try to trick me into some version of, this is what I did. Can you just tell me if this looks good so far? That's not cool. I mean, I shouldn't say it's not cool, but like, that is not like an appropriate dialogue for me to have with you during an exam. And that borders on, and that actually makes me uncomfortable sometimes, because there are different ways where people have of sort of making it seem like they're not doing that when they really are. And that's when it borderlines being unfair to other people who wouldn't think to do that. And this is not what Claudia is talking about. And Claudia wouldn't do that. I mean, honestly, I'm pretty sure. But so you can't text me for like help, and you can't disguise help as can you just tell me if I'm on the right track so far? People say that. I don't like that. I'm saying it now so no one's offended, okay? But you definitely can text me in the middle of exam like, wait, professor, question 4, you said, whatever, in part E, you referred to part C, but there is no part C. Could you explain? Definitely something like that, you should text me. And then I will publicize to everybody, and then you should check the public. Okay, I think it's clear. Okay. Yeah. Okay, so sorry. Okay, so that's Claudia's thing, and yes, Paulina, right? Yes, Claudia, right? Okay. Oh, also, I know you guys are like replying. Oh, no, okay. Okay, okay. So that's all that. Now, I'm even going to get back. I think that's everything in the chat, I think. And hi, Christina. Yes, hi. And hello, Shirley. Sorry about that. Okay. Now, you know what? What I was going to do this class, I'm going to tell you right now, because I think you guys are being very like engaged and engaging. Well, the plan, what I was going to do was go straight to the last two questions of homework two, because we still haven't done that. And then I was going to start trying to prepare you for homework four, which technically was due today. But you know what? Because a number of you have just asked, and I know there's a concern, and I don't want you to feel stressed or fall too far out, I will flip the order. I don't want to confuse anybody. So let me make this clear, and then you'll tell me in the chat is clear. I'm going to flip. I'm going to, in other words, and also to encourage you to think that your participation really does count, because it does. I mean, to let you know that this class is really yours, not mine, since at least two people in the public chat and at least one or two people in the private chat have already made it clear to me that they're nervous about homework four. Yeah, I'm going to jump right now. Before I even go any further over the prior homeworks, I'm going to jump right now to the larger concepts and equations that come next that will help you with homework four. That's what I'm going to do first. Then I will go back and start applying things for, okay? Just again, to show, like, yeah, when you guys have, I'd rather do what you want me to do when I can than the reverse. But I hope it doesn't confuse anybody if I do that. In other words, I'm going to sort of try to, well, yeah, I'm going to try to get to this second equation that's on the board right here. That will help you for homework four. But then I'm going to give you some more equations for homework four that are not even written here right now. That's what I'll do in a moment. Clarify two things. One, let me just, I still have to go over two and train of thought three. We're going to skip them momentarily, but we're still going to go back and do them. They're not lost. Okay. I just hope that doesn't confuse people. That's number 1 point. Number two point. Can I do this? Yeah, I can do this. Okay. Number 2 point is technically homework four was due today. It was out of 45 points because it's a big one, right? Just to be clear again, if you already made an attempt to leap to this hard homework and you already turned it in on time and did something thorough and responsible, even if it was totally wrong or even if you got stuck or whatever, you already got, I believe, 36 out of the 45 points or something like that. I mean, depending on who you were. Again, just to remind you, this is like my funny system, how you just keep you could just keep doing stuff and then revising and getting more and more points. I just keep giving you points and more points. So it's all in stages and rough drafts. So if you got like a 36 or something like that, that's an acknowledgement that you're on top of things and you're not behind. I still have not, but I just got it. So I've not revised any detail. I've not looked at any details. I've not given you any feedback. So you don't know me. Don't think you got things wrong. If you got a 36, it doesn't mean I don't know if you got things wrong or right yet. It's just an acknowledgement. Okay, you get it. You get it. So the ball's in my court to do more with your homework if you've already turned it in, not the other way around. However, it also is to say to those of you who have not done it yet or who are about to find out right now when I start talking about it that you think you did it all wrong, everybody can still do it and everybody can still upload revisions or new versions of it. Okay, everything is a work in progress until the exams. Everything is rough draft, revise. Okay, so no matter where you are, whether you tried it already or you didn't, you're still okay. I'm going to start. I am right now. I'm going to shift gears from what I was planning, and I'm right now going to start addressing what the deal is with homework four. Hopefully, it will help all of you in the room, whether you already made an attempt and found it or you didn't. Okay, it's to all. So yes, I'm just looking in the chat. I'm going to skip. Yeah. Okay. So in fact, okay. Yeah. Okay. Yeah. All right. So I'm going to do this in general terms. So who else do we have here? Okay. I'm going to try to give broad strokes here. Okay. So I hope again it's clear. Like, let me know if it's not. I'm going to talk about the things you need for homework 4 and where we are right now in the course. So I'm not literally on sheet for anything right now. I'm afraid if I start getting into the sheet, I'm going to go too slowly and I'll never get back to 2 and 3. Okay. So this is what I'm saying. Okay. This one's here. Okay. I'm just going to change the view on the screen also. Okay. So I'm going to talk in English now for a second. Okay. And I promise this. So again, what I'm about to talk right now is like general concept that you need to transition from homeworks 1, 2, and 3 into homework 4. Now, the interesting thing is in homeworks 1, 2, and 3, even in 3, of course, it's all kind of conceptual, but for all of homeworks 1, 2, and 3, all we know mathematically so far, the only equation we have so far is average velocity is equal to displacement over time. The average velocity for some interval between 2 points in space and time is the displacement between those 2 points in space per the duration between those 2 points in time, right? Average velocity is cool, awesome. Okay, I'm glad. I'm going to do this anyway, but good. Then you're ahead of the game. That's awesome. Shawnee. Average velocity is change in position per change in instant, if that makes sense, right? That's average velocity. Now, in print, and strangely, that's like all we know so far. Okay, okay, wait. Yeah, absolutely. You can. Although, hopefully, since I'm also sort of doing this in response to your question, hopefully this is going to help you a lot. I hope. But yes, you definitely can. Yes. Um. 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 So average velocity, which is all we know right now, is how far you got in a particular direction per how much time. I want to emphasize again, though, before I go on that. So this, and it's always true, right? It's a definition. It's always true. That's its advantage. It's always true, even when you don't know what to do with it or how it's relevant. It's always true. The disadvantage of average velocity is that it refers to, it picks out the one number that describes what's going on between 2 points in time and space. Average velocity refers to an interval, a segment, a region between 2 points in time and space. And 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 a lot could be going on between those 2 points in space. There could be a lot of changes like average velocity. So what average velocity doesn't tell us anything about is how fast we're actually going at some particular point in time and space, right? Again, if just to everybody, just to remind you, if I travel 60 miles in 2 hours, that means on average during those 2 hours, on average, I'm traveling 30 miles per hour. My average velocity for those 2 hours would be 30 miles per hour. What does that mean? It means I will get exactly as far as a car that was always going 30 miles per hour during those 2 hours. That's what that means. But does that mean that I was necessarily always going 30 miles per hour? No, it doesn't. Right? So to everybody, what I want to say is we start with averages always in all physics classes, whatever. The first thing we can like deal with, the first thing that's easy to measure and picture is an average, but is an average between 2 points. But it's not, but it's one value that captures a lot of things that could be changing between those 2 points. It's
I have a question.
Oh, yes. Okay, let me just okay. So, so my sentence just is that averages are good because we can picture them and compute them easily, but they're not exact. They are one representative value for a whole range. So now we have to move on in this class to how do we get like an exact value for one point in time and space, and that's where I'm heading to next in this. But okay, yes, question. Let me just change the view. Is that who? I just saw who was it that asked it. But yeah, was that Shawnee or who was just asking a question?
Oh, I was asking a question. It's
Oh,
kind of related to this. I remember seeing it on the homework, but how would you find the speed from velocity? Is it
what?
possible?
Oh, to find speed from velocity? Oh,
Yeah.
they in as long as you're talking about one segment, if you're in one segment, if you know the velocity, the speed will just be the absolute value of that. Like speed is the magnitude of, if we're talking about average velocity, if you know the average velocity for, oh, I know, oh, great, I'm gonna get Josephine next. But yeah, if you have one, so for example, if a car goes 60 miles to the south and takes 2 hours to do it, and if we're calling south negative, let's say, so if a car goes 60 miles to the south in 2 hours, then its average velocity would be negative 30 miles per hour. That's its average velocity because velocity takes into account direction as well as size. But what would its speed be? Its speed would just be, speed means whatever the rate is, but not caring about plus or minus, not caring about direction. So if the average velocity were negative 30, then the average speed is just 30, positive 30. Does that make, it's the absolute value, basically. Does that make sense? Okay, good question, Claudia. Okay, and then I think Josephine just had a hand up, or
Yeah, you kind of answered my question already, though. I just wanted to make sure. So, like, velocity accounts for the direction of the speed, and then speed is just like the speed, if that makes sense.
it totally makes sense. Yes,
Okay.
exactly. Yeah. Hopefully it does. And hopefully it also makes sense to Claudia, because yes, you're on the same page, the two of you. Yes, totally. Yes. Okay, wait, and there's something in the chat. I think, let me just see. I think I got what was in the chat. Yeah, okay. So now, what I'm trying to get at now is there's this funny thing, like we've been defining and using V with a bar over it, but and that means average velocity. The V stands for velocity, the bar stands for average. But the funny thing is we never actually yet talked about, well, what's like velocity by itself? What is just velocity? And that's not an accident, not because we messed up or we forgot something. This is the way it goes in physics. Averages are easier to compute and picture, so we do them first. But what V is without a bar on top of it, V by itself, just what you might say like regular velocity, what we call it in physics is instantaneous velocity. V without a bar on it is the velocity that something is going at one point in space and time. It's not the average between two. It's what the thing is doing at one. So, so with, okay. Oh, sorry, homie. Okay, so what I'm saying here in English right now, say you have a movie of a car driving down the highway. You make a movie of a car. Average velocity of the car is like on average how fast the car went during the movie from one early frame in the if you picture a movie as like a bunch of frames, a bunch of snapshots, a bunch of pictures, put together, right? If that's what a movie is that we zip really quickly through a bunch of pictures. If that makes sense. Then like average velocity is like how fast something's going between one early picture and one later picture, one early snapshot, one slice in time and space, and one later one. Well, instantaneous velocity would be how fast the car is going just at one snapshot, right? But that's a little weird. That's a little weird, like how fast the car is going at one frame. But that's a little weird because if you remember that average velocity is change in position over change in instant, change in time, right? Then if you want to look at how fast a car is going, just not between two moments in time, but just at one moment in time, that's a little strange. If you do it too carelessly or too quickly, what you might think is, okay, then the denominator of this fraction would be 0, it seems, right? Because no time has passed at all. It's not between 1 o'clock and 2 o'clock. It's not between 1 o'clock and 1:30. It's not between 1 o'clock and 1:01. It's just like at 1 o'clock. So you'd think that you would put like a 0 in the denominator for how much time has passed. And then you would think, okay, well, how far did the car get? Like between its initial position and its final position? Well, if you're just looking at one moment in time, the initial position and the final position are the same. There's only one position, right? So the change in the position, you would think, would also be 0. Like I'm putting question marks here, right? I'm saying like if rate of speed or rate of velocity is how far you get per how much time passed, if we're now going to look at what's going on at one point in time, well, then time hasn't passed. And then you didn't get anywhere, right? So you'd think that if you're just plugging in numbers a little bit too casually, it would seem, sorry. right? It would seem like we're going to get 0/0 every time. If we too carelessly calculate velocity at a moment, it would seem that we would get 0/0 every time. And that's a little crazy, I think you can already see, because on the one hand, 0/anything is 0. So on the one hand, it looks like you might think, well, then at one moment in time, you're never going anywhere. But that can't be, because if you're never going anywhere at any point in time, then no matter how many points in time you string together to make a full movie, like if every single snapshot of a movie, if in every single frame of a movie we're not going anywhere, then no matter how many frames you put together, how are you ever going anywhere in the movie, right? So either it's going to look like it's 0. So 0/anything is always 0. That looks weird. But you also know from math that anything divided by 0 is always undefined or infinity or something like that. So that would imply that that you can't even get an answer to how fast you're going at any given moment ever. But you also know that any number divided by itself, like 7 divided by 7, or 4 divided by 4, or x divided by x, is always 1. So it would seem, if we're not careful about this, if we start talking about how fast something's going at a moment, it would look like we get this crazy answer of 0/0 every single time, which would seem to mean that it seems like the whole idea of moving at a point in time is meaningless. Like, that's what this sounds like it's saying. But that cannot be right, because when you're driving down the highway, or someone's driving down, or you're in a taxi driving down, and the police pull you over and they say, woo, do you know how fast you were just going right now in that school zone? Do you know how fast you were going? You can't say to a police person, well, let's see, sir, ma'am, like, I've been traveling for the last 3 hours, and in the last 3 hours in total, I've only traveled 30 miles. So on average, 30 miles divided by 3 hours is 10 miles an hour. So on average, I'm totally driving below the speed limit. So I don't see what the problem is. No, you can't say that. That's not what the policeman is pulling you over for. They don't care about your average over the last 3 hours. They're saying how fast you were just going when you just passed the school or the traffic light or whatever, right? They're talking about how fast you're going right at an instant. And there clearly is a meaning to that. So but it can't be, and you can't say to the policeman, well, it's 0/0. I guess it's undefined every time. I guess you can't give me a ticket. Like, no, there's got to be a meaning to instantaneous velocity. So what it is this. What it is this. There's a definition now. Okay, this is a new equation, if you like. Now, we're not going to plug. This is not this is the definition. It's new information that I'm giving you right now. Don't get confused. I'm not saying this is not one of those things that you're going to algebraically manipulate a lot. Like, you're not going to plug and chug with this. It's a concept. You might even recognize it from calculus. It's going to lead to, well, in fact, I'll get straight to it. Well, it's going to lead to a calculus thing. But what I'm saying, what I'm saying is this. Okay, here's the important, and I will move on in a second to really apply this to the next equation. It's a homework 4, but as long as we're getting this out, and this is a calculus thing, right? I'm going to say instantaneous velocity at a point is average velocity between 2 points. It is, like, if you want to know the instantaneous velocity right now, not between 3 o'clock and 3:01, but at 3 o'clock. Let me back up. The problem is if you just say the average velocity between 3 o'clock and 4 o'clock, that's approximate. That's the average for the whole hour, but it may not be exactly what's happening at 3, right? Like it won't help the policeman. That's average. But if you want to know how fast you're going right now at 3 o'clock, the problem with that is if you literally say at 3 o'clock, if you literally say, I want to know how fast I'm going on average at this point in time where no time has passed at all, if you literally say 0 time has passed at all, well, then 0 time has passed and no one got anywhere. So the answer is going to be 0 over 0, which doesn't make any sense. So when someone talks about instantaneous velocity, when the police person says, how fast were you going right now? What they actually really mean is a calculus thing. What they actually really mean is, how fast were you going on average during a time interval between 2 points that were far enough apart to be 2 points? Like what the policeman's really saying is, how fast were you going between, let's say, like 3 o'clock and 3 o'clock and 10 seconds, or 3 o'clock and 5 seconds, or 3 o'clock something. He's saying, how fast were you going between 2 points in time that were far apart enough to actually be 2 points in time, not 1, but close enough in time that they're below the threshold of measurement. Like, we're scientists here, right? We're scientists. So velocity at an instant really means average velocity between 2 instants that are close enough together. That are far enough apart to actually be 2 instants, but are close enough together that we can't measure the difference between them. Specifically, what I mean by that is, like, say our most fancy precise time instrument goes down to milliseconds. Like, and when I say we, maybe I mean the police person in this context, or maybe I mean the physicist in the lab who needs this quantity, or maybe I mean the government, like whatever the context is. If you want to know the velocity right now, what you really mean is you want to know the velocity between 2 points in time that are far apart enough to be 2 points, far enough, but close enough that they're closer than what your clock goes down to. If your clock goes down to milliseconds, then they're like, half millisecond apart. Bad example. If your clock goes down to centiseconds, then they're like a millisecond apart or whatever. This, right? So bigger than 0, but below the threshold of measurement. That's the scientific way of putting it. The mathematical way of putting it is, that's what a limit is. And I'm going to say this very strongly now. The way we write it mathematically is the instant. In other words, what I'm really saying, I'm going to say it a different way here. I'm going to say V with no bar over it equals what I'm really saying. I'm now introducing the word limit, which, again, if you're like me, and limit is from calculus class, of course, but if you're like me, when you first saw limit in calculus class, maybe you didn't, maybe you didn't like it. I mean, I didn't. when I first saw limits in calculus class. And maybe I didn't like it so much that if I'm now introducing it here in a physics class, it might be a turnoff. And you might say, oh, great. Now he's like using a calculus thing that I never understood in order to explain this. Flip it, go the other way in your mind. This might be the first opportunity to understand what a limit is. Limits when we say in the limit as when we say in the limit as t approaches 0, we always say in math class, like we mean t is as close as it can get to 0 without actually being 0, right? And that's confusing, especially in a math class at first, right? But what I'm saying is think of it scientifically. When we say t is as close as it can be to 0 without actually being 0, what we're really saying is it's not 0, it's there, it happened, time passed. But it's close enough to 0 that I can't catch on a measuring piece of equipment exactly how much time passed. It's just too small. That's what we mean by limit. So what I'm saying now is instantaneous velocity is average velocity taken to the limit. One second. I'm saying if we were to make a position time graph of a car going down the highway, where position is the y-axis and time is the x-axis, no matter how complicated I'm saying displacement over time is average velocity. Average velocity would be the slope of that red line connecting 2 points in this position time situation. If we bring those 2 points so close together that they're as close as they can be to each other without actually being 1 point. In other words, if they're immeasurably close to each other, but they're still 2 points, then what we've taken is the slope of that line. We've taken the average velocity, the displacement per time in the limit. So we've gone from delta x over delta t. We've gone over a regular finite rise over run to an infinitesimal rise in the graph, to an infinitesimal run. There's a lot of language to say in the end. So for some of you, so what I'm saying is this, and I'm going to move on in a minute. Just let it sink in. What I'm saying right now is instantaneous velocity, v at a point, means average velocity between 2 points taken to the limit as we bring those 2 points closer and closer and closer together. So if average velocity is the slope of the line connecting 2 points on a position time graph, then instantaneous velocity is the derivative. When we go from, I'm literally saying this. Yeah, I'm just going to leave it at that. Sorry, I'm saying when we go to the limit, we change from slope to derivative. I'm saying that a new equation, if you like. Now, I'm not saying yet how to use it. I'm going to get to that in a minute. Or this is not an algebra thing. You can't like open it up and start remanipulating and plugging and chugging with it yet. I have to get to that next. But I'm saying as a new definition or as a new concept, average velocity is displacement over time between 2 points. Instantaneous velocity is the limit of that as the 2 points get closer and closer to becoming 1 point. So instantaneous velocity is the derivative of position with respect to time. It's the derivative, that concept from calculus. That doesn't tell you what to do with it. It doesn't tell you how to do anything with it. It doesn't tell you how to calculate it yet, but I'm just saying that it's true, okay? That from here on in, if ever I say limit or I say derivative, I mean that. I mean, we're squeezing 2 points in time and space so close together that we can't measure how far apart they are. But they're still so far apart that they are 2 points, not one. That's what we mean by limit and derivative from here on. Now I'm going to go on. I'm not even going to ask just because I feel like I'm losing people. I mean, you could certainly put questions in the chat or whatever, but if you're thinking right now, what is this? You might be confused because it seems abstract and mathematical. So let me get a little bit more practical for a minute, and it'll make it more concrete for some of you. Okay, I'm starting to get slightly more concrete here, and I'm going to back up and review this in a second. But what I'm saying now is, okay, up until 20 minutes ago, we only had one concept, one definition, one equation in this class. We just had average velocity equals change in position from here to there per change in time from now to then, right? Average velocity was the difference between 2 points in space per the difference between 2 points in time. That's all we had. That was average velocity, okay? Then the last 20 minutes, what I've been trying to say, kind of in more way than one, and if any, and again, in the last 20 minutes, I've been trying to say one thing, but from sort of different perspectives. So if anything I said worked for you, then just hold on to that. If you didn't get everything, it's okay. What I'm trying to say in summary in the last 20 minutes is, fine, average velocity may be how you change your position from here to there per how the clock changed from here to there. But now I'm saying instantaneous velocity, our new concept, instantaneous velocity is the rate at which you're doing that at any one point. And if you're a little bit confused by that, you should be. I'm saying this is a harder notion. This is a harder notion. It's why we don't start off with it. And when I say we, I don't mean students. I mean all physicists. We don't start with instantaneous velocity because it is harder to get our mind around. And really, honestly, the reason that everybody's required to take a full semester, if not two, of calculus before they even talk about this in physics is because it really is a calculus, because it took us centuries to develop a thing called calculus to get our minds around this. So, okay, so I'm not trying to skip. I know you're required to take calculus to take this class, but I also know in my heart of hearts, that doesn't mean everybody feels comfortable with calculus at all. I don't think you do. I don't expect that you do. I didn't either. What we are saying here is calculus is one way of saying something. Physics is another way of saying the same thing. They're both very tricky. It took the human species centuries, like actually millennia, to develop this way of capturing intervals of time and space that are infinitely small. That is what calculus is honestly about. That is what I'm getting to right here. So if it doesn't immediately land on your head, don't think it's your problem and don't be angry at me either. The complicated idea that I've been trying to say for 20 minutes is, wait, how fast you're going at a moment has to be kind of like it can't be how fast you're going between two moments. We already have that. That's called average. But it can't literally exactly be how fast you're literally going at one point either, because if you really think about it, that doesn't make any sense. There's never any motion in one frame of a movie, right? So it's this in-between idea. The idea of instantaneous velocity is a very tricky idea. If you're slightly confused, good, be honest with yourself and admit that. Really, and then just like give it a while to sink in, because it is a tricky idea. And it's what all of calculus is honestly about. We just get so swept up in all the equations and the problem sums, we forget. What we're talking about now is instantaneous velocity, is how fast you're going in an interval of time that's big enough to actually be an interval, but small enough to be below the threshold of measurement. So that's what instantaneous velocity is. So now from here on in, we say that we have it. Like we do this calculus thing or this funny thing in our mind, and we say from now on, it's reasonable for a police person to pull me over and write me a ticket and say, right then, at that stop sign, Yaverbaum, you were actually going 75 miles an hour. I don't care that on average for the last 3 hours, you were only going 30. That might well be because you were going super slow all the other moments. But at that moment, you were going 75 and I'm writing you a ticket and you can't contest it. Now, that notion makes, I'm saying that's a real idea, right? What the policeman's really saying is, he's really saying over that millisecond that you passed the stop sign, you covered like 50 centimeters. And when our computer did the division of 50 centimeters divided by 1 millisecond, that turns out to be an enormous number of 75 miles an hour. And we're saying 1 millisecond is so small that like we know that if you're going 75 miles per hour on average during that 1 millisecond, there's no way you had time in a millisecond to actually change your speed that much. You cannot tell us that even though on average you were going 75 for that millisecond, actually for the 1 femtosecond that we're pulling you over, actually right then you were really going 30, and every other femtosecond you were going 90. Like, no, it was for a millisecond. There's no way your speed varied that much. We don't have measuring equipment. That's what he's really saying. That is what instantaneous velocity really means. It means in the limit of such a small threshold of time that there's no way it changed noticeably at all. So that's what instantaneous velocity means. So from here on, what I'm yelling at, because I know it's confusing, what I'm yelling at is from now on, if you ever see V without a bar on it, you can assume that we have this calculus way of coming up with a number for how fast someone was going in effect, at a moment, at an instant. That's what V by itself means from now on. So then, now I'm going to develop another equation then. Once we accept that, which again, maybe you want to think about it more at home, but once you accept that the idea exists, or that the idea applies to reality, then we say, well, okay, then you can change your instantaneous velocity from one moment to the next. Like at the stop sign, you were going 75. Maybe at the truck stop 4 hours earlier, you were going 20. Like your velocity can change. You can have one average for the whole period of time, but your velocity can change from one point to the next, just like your position can change from one point to the next. So we develop the next definition, the next concept. The next concept is called average acceleration. So this is new knowledge now. This is totally what you need for homework 4, for what it's worth, whether you tried it already or not. So it's not new if you looked at homework 4, but I've never said this in the class yet. I'm not assuming, I'm saying it. I'm saying it's a new definition. Just like average velocity was defined to be change in position per time, now I'm saying average acceleration is defined to be change in instantaneous velocity per time. I'm going to re-summarize these equations on the next page in a moment. But notice, I'm literally introducing a new equation now. I'm introducing it. I'm not deriving it from anything. I'm introducing it because it's a definition, just like the old one was. But they look very similar. If you think they look similar, you're right, and it's not a coincidence. We're saying average velocity is how you change your position from here to there in a given amount of time. average acceleration is now how you change your instantaneous velocity from here to there in an interval of time. So I'm saying thus far we have, this is our equation sheet so far, if you like. Thus far we have in effect 3 equations so far. Okay, the middle equation took me the long, it's not a coincidence. The middle, so we now have 3 equations in this class, okay? The middle equation, I mean, which you can write 2 different ways. It's 2 different, the middle equation says that instantaneous velocity is the derivative of position with respect to time. It's the limit of average velocity. The middle equation took me the longest time to explain because it's the hardest concept. Again, if you're at all confused by the middle, that's fine. But don't give up and don't get frustrated and don't give up. Like that is the most confusing of the concepts. It takes a while to think about. It relates you back to all you. For some of you, it helps to think about it in a calculus way. For others of you, it might be the first time you might start seeing what all that calculus was about. It can go in both directions. But no matter what, that middle one is a super important concept. It's not something we really use for algebraic manipulation. You're not going to plug and chug into it. You just need to know that it's true. The other 2, okay, we're going to start using, especially in homework 4. I'm going to do, right, yeah, so, okay, so, yeah. Okay. I'm using a lot of car analogies, which I mean, it's like sort of annoying. I mean, I'm just wondering if any of you, who's showing video, do any of you, this is like a stupid question, but just to keep us awake and everything, whether you're showing video or not right now, could you just raise your electronic hand or your electronic thumb or something if you've ever driven a car? I don't mean that obnoxiously, but like who here has ever driven? Oh, so many of you have. Oh, okay. Oh, and in fact, the people showing video in particular. Okay, cool. That's a lot. And I don't expect that everybody has, but that's a lot. Okay, and I know everybody's been in a car. But okay, if you've driven a car, I just want to make, and this is like a funny thing about physics that all of our, whatever, a lot of any example we ever pick in physics is like gonna be relatable more to some people than to others. But the thing with the cars is like, I just want to drum in. And again, I'm not, everything I'm saying here is not going to just like solve homework 4 for you. I don't want to be creating illusions of that. Because this again is where physics starts getting conceptual and sort of challenging. The challenge is not manipulating the equations. The challenge is like understanding what's behind the equations. So again, I just want to say a shout out, like I'm very glad Claudia and other people asked me to do this. I think it's the right thing. I think this is what we need. I don't want to discourage them or anybody else. Even if you're thinking like, okay, this is great, but now I'm still looking at the homework right now as he's talking and I still don't know how to do that. That wouldn't shock me, and it shouldn't shame you either. Like you will have to, I will still say, now that you are seeing this, if you go bit by bit, step by step in the homework, it's probably less hard than it looks at first. But yes, we're getting into a concept now that needs time to sit in. And a lot of the point of all these homeworks, I know I'm getting so defensive, it's always, but remember that the point of the homeworks is practice. Like a lot of these things, no matter what I say, they just don't make sense until we start practicing them. And practicing is like with the piano. Like practicing means getting things wrong, feeling the wrongness, then correcting the wrongness, and then feeling the rightness. Like don't like this. Even if this just gives you enough to do the homework and do it wrong, you will still have benefited heavily because then you'll know how to tweak it. But none of this makes sense in the abstract. I know that. Anyway, that said, so I'm going to keep going with it though. And soon, maybe we have 13 minutes. I may literally open up the sheet and start talking about the sheet, even though I still know we've never yet talked about homework 2 or homework 3. I know that, but I just want to, we will. But what I'm trying to say is this. Yeah, this is why I just made that whole speech. Because I can promise you this from 30 years of experience, so much of physics, no matter what level we're talking about, so much of physics boils down to the relationship between velocity and acceleration. It is a huge relationship in physics at all levels. It's simple, but it is not easy. At all levels, people find themselves with their brain jostling like, wait, I thought I understood. Like velocity and acceleration are so similar in a way, so on purpose similar, but they're so different in another way. If you're ever consciously thinking at any moment, like while doing homework 4 or any other moment in the next 2 semesters, if you're literally ever consciously thinking, wait, I'm still not sure I totally get the distinction between velocity and acceleration, then that's good. Then you are good. Because honestly, most of the times that we're confused with physics, it is because we're confused about velocity and acceleration. Most people don't even have the conscious clarity in their mind to realize that's what their confusion is. If ever you can admit to yourself that you're not 100% confident about the distinction between, or the relationship between velocity and acceleration, then you have joined the physics club. Welcome, welcome. And I'm not being sarcastic. I'm yelling about this again, because I'm sort of like pleased that Claudia and others sort of like forced me to like get to this now, but I want you all to know this is where the rubber hits the road already. Velocity is really similar. Let's go back for a second. The 2 equations, this one and this one, look remarkably similar for a reason. They are analogies. They are analogous, but they are different. They have different content. If you really are good, you'll realize that calculus was all invented in a way to capture this distinction. If you're comfortable with calculus, you might understand that what I'm ultimately saying is velocity is the first derivative of position with respect to time. Acceleration is the second derivative of position with respect to time. I'm going to say that one more time. For those of you who know at all what I mean or feel at all comfortable with those words, please write it down. I'm going to say it again. For those of you who are not comfortable, don't shut down. Don't turn off. Just let these pieces come together and start realizing these are the pieces we have to practice. So I'm going to say it one more time. Velocity is the first derivative. I'm going to write it, in fact. I'm going to say velocity is the first derivative of position with respect to time. Like this is all assuming position is some function of time. If position is some function of time, which it always is in physics, velocity is the first derivative of position with respect to time. Acceleration, what I'm ultimately saying is acceleration is the derivative of that. Acceleration is the derivative of velocity. Velocity is the derivative of position. Therefore, acceleration is the second derivative of position with respect to time. Oh, I see the hands. I'm sorry. I'm going to get the hand. I just want to say again, if that helps you now, good. If it doesn't help you now, if it just slightly scares you now, I understand, but write it down anyway as a note to self. And as to me, something that that's what we have to start thinking about. I'm going to say one last thing, and then I'm totally going to get Maria and someone else had their hand up. But one other thing, what I'm trying to say is, well, I'm trying to say two things. It's not a coincidence that we have this mathematical language for this. We're saying they're both super similar, acceleration and velocity. They're both super similar in that they're both rates of change. They're both derivatives. They're both the rate at which something changes, but they are different rates. One is derivative one, one's derivative two. In English, and I will shut up and I will get Maria and others, I'm saying velocity is at some moment how fast your car is actually going at a moment. That's what instantaneous velocity is, how fast your car is going at a moment. But if you're driving that car and you're looking at the speedometer, and let's assume it's for a moment, and I will get Maria, I'm not forgetting, and I'm sure we'll like sort of act like it, Maria pretty much will be done for the day, and that's fine. But if you're looking at an old-fashioned speedometer, like on your dashboard, I mean, you could be looking at any kind, but let's assume it's like old-fashioned. So there's like actually numbers written there, and there's like a needle that when the car's parked, it points to 0. And then when the car is going 30 miles an hour, like the needle points to the number 30, like that type of thing, right? What I'm saying is your car could be going really fast. Your car could be going 80 miles an hour, so its velocity is 80. But if it's always going 80, the needle in the speedometer is sitting there at the number 80, right? The needle would be parked at the number 80. It's saying your car's going really fast. It's going 80, but the needle's just sitting there at 80. If you start to speed up, if you start to change not just where you are, but start to change the rate at which you're changing where you are, if you start to change your speed, then the needle starts moving, right? The needle doesn't move just because the car's moving. The needle moves when the car moves its motion. The needle doesn't move just because the car has speed. The needle moves if the car's speed speeds up or speeds down or whatever. So acceleration is the speed of the needle, the velocity of the needle, not of the car, of the needle. Acceleration in rough English. In calculus, if I say acceleration is the second derivative of position with respect to time, if that's what I say in calculus terms, in English, what I'm saying is acceleration is the speed of the speed. That's what I'm saying. I'm going to pause for it. Now, again, that doesn't solve homework sheet for you. But I will say that it gives you all the concepts and the equations that you need for homework 4. Like that's all we now have 3 equations instead of 1. We had 1 before, we have 3 now. That's a lot of progress. And those are the concepts that you're using for homework 4. I'm going to pause. I know Maria, sorry. We have 6 minutes. Sorry, Maria, I think you had a question, Maria, or maybe she was reading. Yeah.
Question.
Right,
So
okay,
one more question on velocity, because if you're told that something is moving at a constant velocity, then does the instantaneous velocity change at any point?
Perfect question. If something is moving at a constant perfect question. If something is moving at constant velocity for some segment or interval or experiment or some period of time, if you know that some interval of time and space that the thing is moving at constant velocity, then literally what that means is its instantaneous velocity is not changing from any moment to any moment in that interval. Like that's a perfect question. Like, right, if I say velocity is constant, that means instantaneous velocity is always the same. In fact, that's such a good question. I'm gonna put that in mathematical notation now. If velocity is constant, then this means 2 things. The way we can put that mathematically is 1, what that means, and I'll write this a lot in homework sheets and exams and stuff. If ever you see something like the mathematical way of writing what Maria just said, because again, a lot of this is like I talk in English, right? But what we're trying to really, a big part of Physics 203 really is starting to convert and translate all these English concepts into mathematical symbols, right? And so from here on in, a lot of times you'll see on homework sheets and stuff, we won't even say in English velocity is constant. We'll just literally write V without a bar on it, equals V naught. What does that mean? That means at any given moment, the instantaneous velocity is whatever it was right at the beginning, right? V naught means initial velocity. Remember, like V naught, we defined this notation a couple days ago. Like this is going to be a perfect question to end on, I think, honestly. Like remember, V naught means the value of V when t equals 0. Like V naught isn't necessarily 0. It's whatever the velocity was at the beginning when t equals 0. So if anybody ever writes, and that's instantaneous, these don't have bars on them anymore. These aren't averages. So if anybody ever writes the instantaneous velocity at any given moment, V, is exactly the same as what it was right at the beginning, that's a mathematical way of saying velocity is constant. That's what we're saying. Velocity is constant. Now we're not. That doesn't necessarily mean. It doesn't mean that V equals 0. But right, it doesn't. It could be anything. It could be 4, but it's always 4. But I'm now going to take this one. Well, first of all, wait. That makes sense so far, right, Maria? Or like that? Okay, cool. So
Yeah.
now I'm going to take this one step further because again, that question is like a good lead to other things. What it does mean, if you're following this whole discussion, anybody, I mean, you know, any of you, Claudia, Maria, anybody, if you're following this whole discussion, if someone ever says from now on V equals V naught, if they say velocity is constant, what that necessarily does mean, what it does mean is that A must be 0. I'm going to say that slowly, and that'll be the last thing I say for today. But it also does help with homework 4. If velocity is constant, that doesn't mean velocity is 0. It could be constantly 30. It could be miles per hour. It could be constantly 12 meters per second. But if it is constant, that means, if it is constant, it means that whatever it is now, it was then. It means that the difference between any two velocities for any period of time is 0. And this is not a 0 divided by 0. It means no matter what time you look at, the change in velocity would be 0. So if you know, this is a truism. I'm not saying like memorize this as a formula, but get it as a concept. If you're understanding what I'm saying about accelerate, this is a perfect example of how acceleration and velocity are totally related, but they're not the same number. They're not the same thing. If your velocity is always 32 miles per hour, if your velocity is always 32 miles per hour for some experiment, then your acceleration during that experiment was 0. Because if you're always going the same velocity, you're not speeding up, you're not slowing down, you're not changing your velocity, then you're not accelerating. You're moving, but you're not accelerating. All right. So again, this was, I'm not even gonna, I hope, I personally am very pleased that a number of you in the chat today, like literally this is different from what I was gonna do. I was gonna do this eventually, of course. We're not off the topic at all. But I did it in a slightly different order just because some people asked. And I want to say again, I think that was great that they did. If I can't answer a thing, I won't. I mean, don't worry about it. But I think that the people that asked me to do this today, I think it was great that they did. And I'm saying that partly to re-encourage other people to feel like they can do that too, or whatever, but also to encourage those people, even if after all this, even if some of those people are like, oh God, do I regret this because I didn't understand a word he said or whatever, please don't regret it. Because if nothing else, even if you feel right now that you don't understand anything I said or you don't see it, you at least just got more time to think about it this way by me saying it earlier, honestly. So I think I'm pleased that so again, next time, you're not going to get new homework for a while. Remember that too. I will do more catching up with you before I assign anything new. So you guys just catch up with whatever you haven't done yet. If you want to make readjustments in what you did in homework 4, just based on this, great. But you have no homework due Monday. We're just going to all catch up with each other's. And I think, and that is it. So, oh no, thank you. That's very nice. No, thank you for saying so. Okay, great. So I'm going to hang out for a second for questions, but have a great weekend. Okay, have a nice day. Yes, and I'll turn off the recording. Okay.
Have a great